Good morning, everyone, and thank you all for joining the call to walk through the example that we provided to further explain the unaccounted for energy settlement options that we are proposing in the Real-Time Settlement Review Initiative. This is Christina Osborne with ISO Stakeholder Affairs. I'm going to be facilitating the web conference. James Lynn is actually going to be walking us through the example. And then also on the speaker line, we have Brad Cooper, Haley McKeska, James Friedrich, John Anders, and Don Trethway from the ISO. So we are recording the call. We are going to make that recording available on the initiative webpage. Look for that by the end of this week. That's also where you'll find this example posted. And what we'll do is we're going to, as James is going through the example, we'll pause and take questions. So if you do have a question, please ask it verbally. In case you have any follow-up questions to that, you can do that by pressing #2. We just ask that you identify yourself first. So with that, I'll just go ahead and turn it over to James Lynn.
Good morning, everybody. This is James Lynn. I'm the Senior Advisor here at the ISO for the Settlements Design Team. And based upon the last call, you guys requested us to provide you with an example of how the UFE's portion of the policy is going to interact with our settlement system, what will be the modifications. And so I've created basically 3 examples. We're going to go from the very basic to more complicated, and it will give you an idea of what the settlement consequences are, or the result would be if EIM-BAA decides to not settle UFE, but in essence self-provide its losses associated with base schedules, and then only including the losses associated with the real-time market in our overall UIE settlement of the load. And so what I've done is, in these examples, we start out with, you'll see 5 tables, and I'll walk through each one. The 2 main tables on the left, on the one in the middle, are representing the current settlement of the energy in relationship to base scheduling, having some type of market dispatch, and then having some UFE related off to the difference between the real-time market losses based on power flow and the losses associated with the EIM entity here's OAT loss factor. I included scenarios which has overscheduling, on underscheduling situation, and then as well as a scenario which there is big cost recovery. The 2 tables on the right, the one on the top is basically a restatement of the scenario by applying a 0% loss factor for OAT, and then I put a 0% RTD. What that represents the fact that we are not going to settle the 3% RTD powerful loss factor. It will look from a settlement perspective as a 0% RTD loss factor. And then the table below that would be the relatively new settlement for this scenario. Now, on the spreadsheet, I also included a bubble which describes the BCR transfer, and we'll have more discussions related to that once I get to the BCR-related example. So to start off, let's set the scenario, that the basic scenario. In this scenario, at the T-40, this particular balancing authority area, it comes in, it's trying to meet a demand forecast of 1,100 megawatts. So it supplied generation to exactly meet that demand forecast. In this scenario, the OAT losses are 2%, so therefore when we calculate the hourly load-based schedule, I'll take the base generation, and since there was no imports or exports, that's why I'm saying this is really a basic example. we will calculate the hourly load-based schedule as 1,078 megawatts. As you can see, there's a 2% loss factor that is being applied in the base schedules in order to come up with the load-based schedule. Now, going into the real-time market, you're balanced, and you'll see in column or cell J4 that based upon the balancing test, you pass. So by passing the balancing test, the overscheduling, underscheduling penalty will not be triggered. And also based upon the market clearing, we're going to say a generator within this balancing authority area was the marginal unit, and therefore the real-time LMP was $55, which is equal to its bid. And we're only going to look at these examples based on an energy component. We're going to assume that there are no congestion or losses in this particular example. So under this condition, when we apply the real-time market, the demand forecast increased by 100 megawatts, but you also had 100 megawatt export for ETSR. It means another balancing authority area needed 100 megawatts to serve its load. So the generation inside this balancing authority area was dispatched to 1,300 megawatts, 100 to meet internal, 100 to meet external. Now, when it comes to meter data, when it comes to after the fact, this generation actually produced an additional 50 megawatts. This could have been due to regulation or just simply that the generation outputted more. And where that extra 50 megawatts is going to serve, it's going to serve internally because the after-the-fact tags for the ETSR was at 100 megawatts, which was equal to its dispatch. So that means you did not have any additional energy leaving the balancing authority area, so therefore it had to apply to internal load. So when we calculate the hourly load meter, it's going to be the 1350 meter value from generation plus the 100 megawatts of export, so that means it's 1250, and then we're going to apply the 2% loss factor. That results in a load meter of 1,225 megawatts. Now, from a market perspective, the generation was dispatched based on a 3% loss factor. So when we start looking at the calculation of UFE, we will look to see what was the generation, what was the difference between generation and demand, and then with a real-time market loss factor of 3% versus, and with that, it comes out there's a 13 megawatt differential between the generation that was supplied and the load that was consuming it. And with it having a 13 megawatts, because the loss factor was less than the market flow loss factor, then we have we've had too much load on our load meter than we did actual for generation. And so that would result in a UFE payment, and I'll go through that in a second. So
hey,
under
James,
this, yeah.
Hey, James, this is Brad. I just think it might be useful if you could go over one more time what the numbers are that you subtract to get the 13 megawatts.
Sure.
The UFE is 13.
Right. So with the, and let me do it. I don't know if you can see me doing it. Let's see. Equals this plus this okay, so there's your loss factor, okay? So now when I add the generation of 1,350 plus the export of 100, that gives me 1,250. And then I will subtract out the load that was submitted as a meter, which is 1,225. And then we also will subtract out the losses of 37 megawatts, or 37.5 megawatts. Now what this results in is when I add these all together, I don't know if it'll let me do it, equals. I have a differential of 13 megawatts. So what that is that's the difference between your 2% loss factor that was applied to the out and the 3% loss factor that was applied for the market power flow losses. Does that help, Ben?
Yeah. Yeah, thanks. That makes it more clear. Yeah.
Yeah. Okay. I can enhance this to include this in the future. So I'll make changes to it so that we can see this, how it's calculated, and we'll republish it. So based upon that, this scenario, we're going to go through the current settlement, and then we're going to see what happens if a EM entity chooses to not settle UFE and, in essence, self-provide losses in its base schedule. All right. The generation settlement for IIE is going to be the 200 megawatts of dispatch times the $55 RTD LMP. So it's a payment of $11,000. In the ETSR, because it's got an export out of 100 megawatts, we're going to take the 100 megawatts times the $55, and therefore it's a charge of $5,500. So that, based on the IIE settlement, I still need to account for $5,500. So now we're looking at the difference between the dispatch and the meter. So for the generation, there was additional 50 megawatts dispatched. So I'm going to take that 50 megawatts multiplied by $55 to come up with $2,750 payment, additional payment to generation. So that generator on that particular day or that particular interval got paid $13,750. Now, the ETSR, since its tag was equal to its dispatch, so there's no incremental OA/UIE settlement. So now we're going to look at the load. Well, the load will settle at the difference between the meter value and the hourly load base schedule. We'll take that differential and multiply it by $55 as well. And then now we're charging them $8,085 to the load for its consumption of the demand. So if you look at it, what it means is I've taken a payment out of $5,500 net from IIE, and then UIE net is $5,335. I'm not balanced, and what my imbalance is 100 and I'm going to do math real quickly, $65. So where is that coming from? So now we have to look to see, is it related to UFE? So when we look at the UFE, we've determined that there's 13 megawatt differential between what was dispatched or metered by the generation and what was consumed by the load if we apply the loss factor by of the market. And so in our settlement, we settle that at the RTD LMP. It would be the load LMP, but in this scenario, they're both the same. So it's 13 megawatts times $55. Now, because of that it shows that I have too much load, instead of being an additional charge, we are actually going to pay back the entity for the excess load that's been charged to it. And so that's going to be a $688 charge. So now we're looking at it, it shows that I've paid out $6,188 of payments and still only have a charge of $5,335. So when that is going to drive our TIEO settlement of $850, which is allocated to the entity, which you guys then allocate out. That's current settlement. Now, if the entity decides to not settle UFE and we are now applying a 0% loss factor, what's going to happen is this UFE quantity is going to get broken into the base schedule losses, which you are self-providing for, and you're self-providing for it by embedding it in your hourly load-based schedule. And then anything dispatched after base scheduling, after T-40, that losses are now going to be incorporated into the load UIE meter, or settlement. So in this scenario, the demand didn't change, the dispatches didn't change. What changed was the calculation of the hourly load-based schedule as well as the load meter. The hourly load-based schedule is equal to the generation, so we applied a 0% loss factor. So now we're saying that everything that was produced in that BAA was consumed by the load within that BAA. And then when it comes to the meter value, we're going to make the same assumption. So when we look at the settlement now, you see the UFE quantity is 0, and so therefore the IIE settlement isn't going to change because the conditions for the generation didn't. The load or the UIE settlement of the generation didn't change, but the load UIE settlement did change. And that's because there's additional 3 megawatts of losses that are going to be incorporated into the load UIE settlement. In essence, this UFE quantity got split to having some of its megawatts included in the hourly load-based schedule and then some of the megawatts included in the load meter. And then when we look at the settlement now, this load meter is now going to be charged $8,250. So the net settlement of my IIE and UIE is 0. It's perfectly settled. I don't have to add any UFE because obviously we've self-scheduled those losses. So therefore I have no RTIEO to allocate out either. So that's a very high-level, simple example. And obviously I've been talking for 20 minutes on these simple examples, so we'll have more fun in the next ones. Any questions?
So again, if you have a question, press #2 to raise your hand.
All right, it looks like we have a couple of questions in the queue. I'll go ahead and get started with the first caller. Caller, you're unmuted. Please go ahead.
Hi, James. This is Judy Kai calling from APS. How are you?
I'm fine, Judy. How are you?
Good, thank you. Okay, so by seeing your new settlement example, I understand now you are kind of accounting the loss at the demand forecast level already, right? And then the actual loss is going to reflect it in the meter level. Is that assumption correct? Okay. So
I'm going to caveat that is say, yeah, because your generation is meeting your demand forecast. Yes, the hourly load base schedule will represent the generation that's designed to meet that demand forecast. And the reason why I'm making a caveat on that, you'll see it in the next example.
And that's
we'll talk about that when I'm overscheduling and underscheduling. Go ahead.
Okay, I'm a little confused of that because when we turning our forecast, it's the aggregation of all our generations and ties, right? And then right now, it's almost like when we turning our forecast or base schedule, we need to gross up whatever our old loss factor or whatever that our estimated loss factors into it. Is that correct? So there's going to be a changes how we turning the number we turning to our load forecast.
So the load forecast is not going to change. Or the demand forecast going to the market should be still the same. What you're saying is the generation that you're using to meet that demand forecast is then consumed by your internal load. So you are perfectly, you're not going to have any losses. So what may end up happening, though, is that when it gets time to actually serving your load meter may be a little bit different because you either need to, as you said, you need to gross up your generation to meet the demand forecast inside your area, because this is part of the problem with the hourly load being calculated instead of actually having load meters.
I guess my concern is right here, we actually going to have loss, right? Whether or not that actual loss will happen. By looking at your simplified examples, almost looks like that actual loss will be start measuring at the demand forecast level, and then we'll reflect it also at the meter level.
You get, yeah, it's pretty much correct. You're self-providing for your losses associated with your base schedule, and then any losses associated with the dispatches are now going to be settled within the market as UIE. That is correct.
Okay, and then so demand forecast as your current stage is 1100, and then in the future state, whoever going to eliminate the UFE, the demand forecast will be 1200, right? That's the gross up of that loss factors. But your generation at a T40 is actually going to be only 1100, right?
So that's why I want to pull away from your description of demand forecast, because the demand forecast hasn't changed. The demand forecast was still the same before you chose not to settle UFE and after you chose to not settle UFE. So what we're forecasting for your area is going to remain the same. That's why the market is still going to be using the powerful losses when settling or dispatching your generation. This becomes more of a settlement mechanism as to where does that loss reside in the meters. And what we're doing is we're splitting it, because you're calculating the load meter, we're saying 10% or 10 megawatts in this case of your loss is associated with your base schedule. And therefore we need to incorporate in the hourly load base schedule. And 3 megawatts of the UFE is associated with real-time dispatching, and that it needs to settle, and we'll incorporate it as UIE.
Can you clarify that again? When you say it's not affecting the demand forecast, but we see the number is changing, right? It's
no,
1100.
The demand forecast. Yeah, but that's the same in the scenario, the base scenario for the current settlement. That didn't change. All it meant was your forecast you had more demand in RTD market than you did going into the real-time market. Somehow there was some condition that changed. That's not related to this UFE settlement. That's just a normal demand forecast change.
Okay. And then when you say the 0% in the new settlement, again, will reflect it in in the meter level, and then that meter level is 0%, but we know, if actual loss will occur. Is that, for example, is 3%, right? That 3% actually will the reality is going to reflect it in our sink. Have energy transfer between source and sink, and it's either reside in the load or in the export. So that 3% actually will happen, but it would just reflect it in the meter level, in either the load or the ETSR, right?
You're correct. The problem is, if you actually want to know what really reflected in the load, then we actually should have load meters. And by calculating your load using an OAT loss factor, you're not actually seeing the real losses.
Correct. But
and that's why there's a difference between how the ISO settles and why ISO, the top-down versus bottom-up approach. If you had the bottom-up approach and you actually had load meters, we would not allow you to elect not to settle UFE because I have to account for the true losses.
I understand that, but even we are using the derivation approach, the actual loss is still going to happen. It's just where we account that for in the settlement. And then in your case, even though, whether it's the old loss factors we embedded in the calculations or the actual loss factors, now it's 0, but those loss energy will be actually reflecting the meter level, right?
Yes, and in essence, then be reflected as UIE under the load.
Right. Okay.
And then be priced at the same price as UFE.
Okay. And then exactly. And then my question would be push it to the next over and under schedule. Is that going to push us to the threshold of that 5% closely?
So I'll adjust that when I go through the overscheduling, underscheduling.
Okay. All right. Appreciate that. Thank you.
But these are, I'm glad we're talking about this. Is one of the big differences between allowing you to be able to do this election versus not having the election available to you is whether or not you're a top-down approach versus bottom-up approach. Top-down approach means you're calculating your load based upon the meters of your generation and intertie, and you're applying a factor. And that factor, it does not represent the true losses. It represents your studied losses that was now incorporated into your OAT tariff. So you could have any given day, your losses could be higher or lower than your OAT-based losses, and that differential will wind up in your load UIE meter. So if your real losses was 4%, then you're going to dispatch more generation from regulation perspective to meet that load. Because the market dispatched 3%, you're going to dispatch another 1% to meet that load, and that differential will wind up both in the generation dispatch UIE and your load UIE. Whereas if the actual load meter was 4%, then you would have had the load meter would be a little bit different. So you might have an increased UFE because of actual meter differences to the real-time market and to what your calculated load versus the 2% to the losses. That's why when we talk about UFE, we say it's typically the difference between your OAT loss and your real-time market power flow loss.
Right. I understand that part, and I know UFE right now is accounted for the difference of the loss factors between the OAT and then the actual. But somehow those loss actually still being accounted for, even though you're doing that, right? So you're still settling those after the loss factors. But if we're going to eliminate that and then the loss factor now is 0, I just want to see where that actual loss is going to be reflected at in the settlement. And I know that in OASIS that we can actually pull the transmission loss, actual loss, report. And I wonder in the future, how is that going to reflect that actual loss? If we want to really evaluate the actual loss of energy through transmission, you know, how are we going to get our arms around that?
Okay, well, there's two things. On a high level, the loss, those actual losses will still be settled. But what they'll settle in your load UIE settlement, and it'll be the same pricing will apply for that energy.
Correct.
Now, we are still going to be publishing out our real-time market loss factor for your BA. So you will still be able to see that lost megawatts on Oasis.
Okay.
What you would want to do then on your side is calculate your load value with the 0% when you submit it to us, but applying your OAT factor when you want to do that other comparison. So you'd be doing some side calculations on your side. All the information is still there. It just would require some additional calculations on your side to determine what you would have sent previously versus what you are now going to send.
Okay, thank you.
All right, Ethan, do we have others in the queue?
Yes, we have another question in the queue as of now. Caller, you are now unmuted. Please go ahead.
Hey, James, this is Tyler with APS. I think my question was semi-answered there. I was just wondering the 3% RTD power flow loss percentage. I do see the megawatts of transmission loss now on Oasis after the previous discussion. But do you just divide that by the load to get the percentage then of 3%?
I do it by the generation, but your output of your generation and ETSR, because that's what the power flow is going to do. Is it's going to look at the demand forecast, say, okay, I see 3% loss, so I'm going to dispatch my generation higher. So that's how I back into what your 3% is. And so when I run a UFE report that I have, what I can see is, one, that the loss factor that the market, actual percentage that the market is using, and the market tends to use it not necessarily as a percentage, but it's actually doing it on a power flow. It actually says these are the megawatts that are lost within your BA. They tend to range around the same percentage. It may fluctuate a little bit, but it tends to be roughly the same percentage. But for the example, instead of modifying the megawatts, I just apply the 3% to make it easier.
Okay, so then you would divide the megawatts on that report by the generation plus the ETSR amount, and maybe NSI if there was some.
Yeah.
Okay, thank you.
Yeah, so that's one of the things we do is we have this UFE report that provides us a running percentage and megawatts that BAA has at every day. And anytime that percentage has a significant jump in one direction or another, we look to see, did we receive all the meter data? If we received all the meter data, was it mapped into my system correctly? So we actually have a report that looks at your average percentage over the last 7 days and compares that day's percentage to that average percentage for us to do some analysis. And that analysis is to make sure we have the correct meter data.
Hey, Ethan, do we have anybody else in the queue?
At this moment, we have no further questions in the queue.
Okay.
So given that example, let's go into the next one. And this one's related to where an overscheduling, underscheduling penalty will apply. In this case, the demand forecast was 1,200 megawatts. The BA came in and they only scheduled 1,100. And in other words, they did not think that the demand forecast was going to be at 1,200, they thought more 1,100 was needed. So you're outside your 1%. So therefore, you failed your balancing test, which is J4, which means that then settlement is going to look to see, are you within the 5% or 10% threshold of the actual load meter in order to determine if we're going to apply a penalty. I kind of scaled this scenario so that we're within the 5 and 10%. So yes, Tier 1 penalty will apply. Based upon your base scheduling of your generation, my hourly load base schedule didn't change. And that's why I wanted to deviate a little bit from our discussion about it being related to the demand forecast, because the hourly load base schedule is actually being calculated by the base generation you provided. It's not necessarily based upon the demand forecast. And so then when we get into the real-time market, the demand forecast didn't change. The only thing that changed was that we had another 100 megawatts of demand in another BAA. Well, that generation is still being dispatched 200. The first 100 is to make up for the underscheduling of your generation coming into the market, and the other 100 is to meet the demand of another BAA. Again, the meter values, we didn't change any of that outcome. It's still generation produced additional 50 megawatts. And then your load metered at 1,225. Given this same scenario, the underlying settlement didn't change. The current settlement didn't change. Current settlement didn't change for IIE, UAE, UFE, and RTIO. But now that we're applying an overscheduling, underscheduling penalty, you are outside of or within the 5 to 10% threshold. So now Tier 1 penalty applies, and so the entity will be charged $2,560. Now, when we get into the scenario where you've elected not to sell UFE and, in essence, self-schedule for your losses, this will have an impact on your overscheduling, underscheduling penalty, as well as your load UIE settlement. Now, again, related to the first example, this scenario didn't change, other than the fact that you underscheduled your generation. Your IIE settlement is still $5,500. Your UIE settlement is now $5,500. So there's no UFE, no RTIO. But now, because we've incorporated some of the losses inside your load UIE settlement, your overscheduling, underscheduling penalty is increased by $53. It's now going to be $2,613. And that is because the overscheduling, underscheduling adjusts, in essence, your load settlement, and that's what the penalty is, and it's adjustment to your load settlement. Any questions on this scenario?
So if you do have a question, press pound 2. And Ethan, let me know if anybody's in the queue.
Will do. Looks like we have one that just jumped in. I'll go ahead and start with them. Caller, you are unmuted. Please go ahead.
Hi, James. This is Judy again from APS.
Hey, Judy.
I have a couple of things I want to clarify on this. I know that when we're evaluating over and under scheduling charges, there are kind of a couple tiers of testing. So the very first preliminary test is like if there is over and under 1% or something like that between comparing our base to the forecast. Is that correct?
That is correct. If you are using the ISO forecast, correct. And I'm assuming in this case you're using the ISO forecast.
Okay, so this is just a quick clarification. When we're doing the forecast comparison of that 1%, that's no loss factors involved, right? And I just wonder, you know, is there some inconsistency when we're trying to perform balancing test, and then the balancing test is based on, you know, the growth of load, right? And then when we're trying to actually doing the settlement of the over and under scheduling charges, we are actually doing it at that 5%, whatever, at the net of the loss. Is there some inconsistencies at the current stage to start with?
Well, we do when we're doing the demand forecast. The demand forecast is, since you're comparing it to the generation and your NSI, you are actually, the demand forecast is without losses. So in essence, it's going to be based on your generation, if that makes sense. So I'm not going to apply the 1,200 times the 3% or the power flow losses, because your generation needs to meet a certain adjusted demand less the losses. So, and that's why I say without losses. So your demand is grossed up in essence, and that, I believe, and that's why the generation we're comparing it to your generation that way. But losses, I mean, in essence, losses are accounted for.
The losses have already been accounted for?
From the demand forecast perspective, yes. So if your true demand was 1,000 megawatts, and we determined that the losses were 50, in essence, your demand forecast is 1,050 because you have to have enough supply to meet the 1,000 megawatts of demand plus the losses.
Okay, all right.
So,
thanks for that clarification. And then so back to my earlier questions, and then so right now, and maybe you already say it, I just want to hear it again. You're saying that actual loss right now is going to be, if we, go into the future state without the UFE, it's going to be reflected in the UIE on low. And then so that 0% is not accounted for any loss right now. Isn't that going to, but the actual loss will still reflect it in that UIE on low. Is that going to push us further, because we have that 5% threshold between, if we fail the first test, right, the balancing test, and then we're going to have to subject with this 5% testing, and then determine that we're going to be subject for penalties or not. Is that not being accounting for that loss factor will push us closer to that 5% threshold?
That is one of the things that can occur, and that's one of the reasons why I added this example.
Okay.
Is if you're at 4.9% prior to, or in your current settlement, because a portion of those losses are being incorporated as UFE, then you would not get the overscheduling, underscheduling charge. However, now that you have assumed to self-schedule your base portion of UFE, and then incorporate your dispatch portion of losses in your UIE, it can take you over the 5%. It could take you up to 5.1%, and therefore the penalty will apply.
Okay. Appreciate your clarification. Thank you.
Thank you, Judy. Any other questions, Ethan?
Yes, looks like we have about 2 more questions in the queue. Caller, you are now unmuted. Please go ahead.
Hey, James. This is Susie with MA Energy. So I would assume actually there are not going to be any changes, with UIE or without UIE for the settlement results. It's going to be the same, except if you have 5% of penalty. That's what I'm saying right now. Am I, correct me if I'm wrong.
So I'm going to make sure I understand your statement. So with relationship to the your UIE settlement, what's going to happen is it's going to include the 3% of the losses, or 3 megawatts of the losses that were originally accounted for as UFE, because you self-provided for 10. That difference then has pushed your overscheduling and underscheduling penalty up a little higher. So now your overscheduling and underscheduling penalty is going to be charged at $2,613 because you have incorporated that UIE in your load meter as well as your base schedule. Or UFE into your UIE, sorry.
Yes, that's my question. So I don't see any other changes because with UFE and without UFE, I mean, with the new change, the results not going to be the same, except just like you said, without that the old factor, the loss factor not included, it would bump up on the 5%. Possible. It depends on how entities does their balancing. So that's only difference I see currently.
Yep.
Hey, thank you so much, James.
You're welcome, Susan.
All right, Ethan, we have one more question.
Yep. All right. Caller, you are now unmuted. Please go ahead.
Hi, this is Jennifer, Idaho Power. So I think Judy asked the question I was going to ask because I was trying to understand on the over-under scheduling why that difference of about $52 on the current versus the new, and I'm guessing that's because the hourly load schedule now is a different quantity under the new UFE versus and without the losses accounted for. So I think that answered my question there. So there is an exposure to potentially having higher over-under scheduling penalties.
Correct.
Under the, okay. And then the other thing I just wanted to clarify was on what your statement on the demand forecast. So that 1,200, you were saying does account for that 3% losses.
Yes. So,
okay.
We're saying is the demand forecast says that supply needs to meet 1,200 megawatts.
Okay.
And your supply is 1,100 megawatts, so now you've underscheduled in relationship to what we expected the demand to be.
Okay. And then one more question. I just wanted to kind of go back to something I think that Tyler had asked about how you calculate that 3%. Can you just restate what that calculation is of how you come up with that 3%?
Sure. It's actually not a percentage. The percentage, so what the market is doing, the market is going to assess power flow. And based on the power flow, it's going to calculate the amount of megawatts that are lost from generation supply to load. And then based upon that power flow, they send that to settlement is at RTD, or this is our final dispatch, and then based on these final dispatches and the market model, the power flow is going to have this much losses applied. We've accounted for this much loss to meet both internal and external load. And so for the most part, when it says for your balancing authority area, this is the amount of losses for the generation that's lost within your balancing authority area itself. Now, once it goes to another balancing authority area, that supply could have additional losses, but that loss is embedded within the loss factor of that other balancing authority area. So when you look on OASIS and it says 150 megawatts, it's saying that the generation from the supply to the demand points within your balancing authority area, we anticipate, or the model anticipates, that you're going to lose 150 megawatts of energy between the supply and that demand.
Okay, so
now,
maybe the question is,
So what we do, and I'm doing settlements at times, is I compare that megawatts over your generation and NSI and come up with a percentage. And so when I have a check, I look to see, am I roughly within your average percentage, which is 3% in this case.
Okay. Okay, that helps. Thank you.
Mm-hmm. Yeah, I could have put in here the megawatts, and if you guys would like, I can actually put the megawatts in that's represented by the 3% and the 2%. I just tried to simplify it, so instead of calculating megawatts and backing into a 3% loss factor from the market, that I just applied a simple 3% loss factor.
Ethan, any other questions?
At this time, there are no further questions in the queue.
Okay. So the next example is building off of the first two. The conditions didn't change for the energy and the dispatching. Only thing changed was that the real-time LMP did not cover the bid. The bid was $56. The real-time LMP was $55. And so now this gives you a demonstration of what happens when bid cost recovery comes into play when you elect not to settle UFE. The IIE settlement did not change under the current settlement. The UIE settlement didn't change. UFE, RTIO did not change, and same with the overscheduling, underscheduling. However, because you have 200 megawatts being dispatched uneconomically, we're going to potentially give this resource big cost recovery. And in this particular scenario, we're going to assume that over the day, they get big cost recovery of $200. That $200 is then being distributed to the balancing authority areas in which the generation was being used. And so what we apply is a very rough calculation of you take the BCR amount and we multiply it by a transfer out percentage. And how we calculate that transfer out percentage, I'll take the absolute value of the transfer out, which in this case is 100 megawatt export, and I'll divide it by the 100 megawatt export plus the absolute value of UIE, and then plus an absolute value of the UFE. And what this results in is $65 of that $200 is going to be transferred out of this balancing authority area and paid by another BAA because that energy potentially that was short went to serve the other balancing authority area so therefore they need to pay for it. The rest of that $200 stays within that balancing authority area and is allocated to the entity, which is typically then allocated to measure demand. So that's $135 stay within that balancing authority area. Now, when we get to the point where we elect not to settle UFE, the amount of big cost recovery did not change. The UIE, the IAE, UFE, and RTIO didn't change. That's still all back to being neutral. What actually modifies and the overscheduling, underscheduling still stays as the original scenario. What changes is that transfer out percentage. And what happens is because we are now splitting the UFE quantity into that portion which is associated with the base schedule and self-provided, and that portion which is now incorporated as load UIE, you are now having a reduced factor in this case from the 13 megawatts is going to be only related to 3 megawatts. Instead of doing absolute value of 13 megawatts, we will do additional 3 megawatts into load UIE, and therefore you are going to have a higher percent of DCR dollars sent out to another balancing authority area versus what is retained within the balancing authority area. And the reason why that's going to occur is, again, is because you are self-providing a portion of the losses within your load-based schedule. And now the BCR transfer mechanism is only going to reflect those losses which are associated with the real-time dispatch. And so, any questions on this scenario? And we're getting near the end of our meeting.
So, Ethan, do we have anybody in the queue?
At this time, we do have one question in the queue. Caller, you are now unmuted. Please go ahead.
Hi, James. This is Judy Tai from Arizona Public Service.
Hey, Judy.
Hi. For this, I want to clarify a couple things. So if I understand this correctly, this BCR transfer, this is almost like an allocation formula. Is that correct?
Yes, it's part of when we do the allocation of the big cost recovery. I'm going to pay your generator exactly the same. Mm-hmm. And now we're trying to determine who has to pay for that big cost recovery. So, yeah, it's part of the allocation methodology.
Okay. So there are a couple of questions. So if we going through this new settlement, then that means we will have a smaller denominator because that UFE quantity is no longer going to exist. And then so I wonder how that inconsistency is going to be handling for settlement, just because if some EIMBA choose to stay as it is, CAISO is stay as it is, and then some other entities choose not to have settling in UFE, how is this formula going to be consistently allocated those charges correctly throughout the EIMBAA?
So that goes back to with the election to not settle the UFE, you're self-providing the losses. So it's whether or not we want to, the losses are being settled within our market, or whether or not you want to self-provide, and then any losses associated with the actual market dispatch is being settled and incorporated in this BCR. That's the difference, is that depending on the BAA, they can elect to self-provide, and in self-providing, they can then, when it comes to UIE, it can be a higher UIE to them or a lower UIE. It just depends upon which way the real meter went. So I'm not sure if that answers your question. But
I think you did.
Now, yeah. And now the BCR transfer, in my eyes, then, now reflects the fact that the loss factors, the loss megawatts that we are now settling are only based upon the energy which was dispatched in EIM and does not incorporate any of the losses associated with your base schedule.
Okay, I gotcha. So another thing is, this formula seems very familiar, right? It's almost like a measure demand, meter demand type of allocation. So does it mean that will affect how the dollar is actually going to get allocated, just because of some people will have a smaller denominators on that ratio calculation, such as like over-under scheduling allocations, flex ramp, and then spinning neutrality allocation? Is that going to affect all allocation-related type of charges?
No, we originally had one of these in the RTIEO. We eliminated that last year with the real-time settlement initiative that we incorporated last year, the Announced Energy Neutrality Initiative. So that the only transfer mechanism associated with each ESR is the DCR one. So there is no other methodology like this. This is the only one where this applies.
Okay. Is this going to affect the RTCO neutralities if for some entities no longer going to have UFE, is that going to somehow affect where that RTCO get materialized and then get caused by different entities?
Yes, and if there is congestion,
right.
Now, again, we settled the UFE at the LMP, and so when you are not settling UFE and self-providing for those losses associated with your base schedule, then those losses associated with the base schedule will not have a congestion element to it because they're outside of our market. And only the losses which are related to the energy imbalance market will now settle, and therefore it'll be incorporated under the load UIE settlement. So that will still be settled exactly the same way. It's just those losses which are associated with the base schedules are pulled out.
Okay.
Or those losses which are self-provided.
Okay, so one last question is, are these 3 tabs that including 3 examples pretty much indicate all the downstream settlement impact?
The only other downstream settlement impact will be related to flexible ramp. If you remember correctly, flexible ramp is based upon UIE. So now incorporating those losses inside the load UIE, it could have a little bit of an impact on the amount of costs that are allocated to you when they're related to the EIM area.
Okay.
And so when we get into the current one is not going to be that much because the EIM area's pricing has not been significant. But when we get to the point where we are doing flexible ramp deliverability, which is next year, the UIE is going to be as comparative to every other area's load UIE. So it could go either way, but yes, it will affect your allocation of your flexible ramp.
Okay, so you will affect the flex ramp settlement charge codes and flex ramp allocation charge codes?
It affects the flexible ramp allocation charge codes. So it'll be the forecasted movement allocation because now you have a higher load meter.
Right.
And then for uncertainty, it's going to be dependent upon the uncertainty allocation to load UIE. And if we have the way the flexible ramp changes are coming is if those areas that pass the flexible ramp test, we are going to secure flexible ramp for generation to meet the EIM area. And so that EIM area will then be distributed to all the load UIE depending upon which direction the load UIE is. Based upon that uncertainty percentage, we go into the buckets. So now, incorporating the extra megawatts, it could have an additional cost allocated to you, but I really can't demonstrate that until we get to the point where we actually have the flexible ramp deliverability changes into our system, both in the market as well as in settlements. I don't know what the impact. I'm only speculating on the impact.
I see. Thank you so much.
All right, Ethan, any other questions?
At this time, there are no further questions in the queue.
Okay, so great. So I know we did receive a request for additional details in the example. So we'll talk offline and figure out when we can get that information available to you. We are planning to post the draft final proposal mid-October, and we will issue a notice once that has been posted with the meeting details. So thank you all for joining us. Greatly appreciate it. Thank you, James, and enjoy the rest of your day.
Thank you, everybody.
That concludes our conference. Thank you for using AT&T Event Conferencing Enhanced. You may now disconnect.